Good evening to all. Today we are going to discuss the first one is explanation of rank of a matrix, which is I already written yesterday, the last session, the definition, followed by one more method with properties and gate question problems. The second one is solving system of linear equation, and in the last session, if there is a time, depending on the problems of these two exercises, we start with the eigenvalues, eigenvectors also. Okay, now, so this is the definition I have given. Now I am going to explain. Non-negative integer means other than negative integer, that is 0, 1, 2, 3, so on. That is denoted by small r. That number is called rank of the matrix if these two conditions satisfy. What is first condition? There exists at least one non-zero minor. See, this is very important. Non-zero minor of order r. Order r means r cross r matrix in the given matrix A. Search, okay. Suppose if you, sometimes we feel difficulty regarding R. Now I am taking a particular case of that rank. Suppose rank is equal to 2 in some problem. Okay, so that you can easily understand these two conditions. Now, according to this rank of the given matrix, what we have to show the first condition? Non-zero minor of order 2. There exists at least one non-zero minor of order 2. Order 2 means in the given matrix there may be many 2 by 2 matrices, but you have to show, you have to search or find a 2 by 2 matrix in the given matrix whose minor means determinant of a submatrix. Minor of order R means determinant of a submatrix of R cross R in the given matrix A. That means I took R is equal to 2. In the given matrix, you find a 2 by 2 matrix whose determinant is not equal to 0. That is non-zero minor means determinant not equal to 0. Okay. Now in the second condition, R plus 1 of this, by this consideration example, R value 2 I considered. R plus 1 becomes 3. So minor of order 3 or more. That means order 3 means 3 cross 3 matrix. You find a 3 cross 3 matrices. Every minor of order 3 means because I took R is equal to 2. So in the given matrix you find all 3 by 3 matrices whose minus means determinant must be 0. Order 3 or more if R is equal to 2. Okay, 4 by 4 all these things. Then only this R is called rank of the matrix. In the simplest way I have given here. That is, it is of the highest order non-singular square submatrix of A. So, suppose A is a 3 by 4 matrix. What is the highest square submatrix? 3 by 3. So, in the given 3 by 4 matrix, if you find a 3 by 3 matrix whose non-singular means yesterday I gave, determinant not equal 0. So, in a 3 by 4 matrix, if you find a 3 by 3 whose determinant not equal 0, then that 3 is called highest order, that 3 is called rank of the given 3 by 4 matrix. Suppose if you do not find a 3 by 3 whose determinant is not equal 0, that means all 3 by 3's determinant in the given matrix 3 by 4 are zeros, then go for next level. So apart from, that is after 3 by 3 means go by down. That is in a 3 by 4, there 4 by 4, 5 by 5 does not exist. So once 3 by 3 determines 0 in a 3 by 4 matrix, go down. Go down means find a 2 by 2 matrix whose determinant is not equal to 0. So that means you always begin in the rank of the problems means highest square submatrix determinant. Find the highest square submatrix determinant. Whenever it is not equal to 0, then that order is called rank of the matrix. There ends the problem. Suppose in a 3 by 4, there are many 3 by 3 matrices. All determinants 3 by 3 is 0. Then what is your next step? Find a 2 by 2 submatrix in the given 3 by 4 matrix. If you get that not equal to 0, then rank is equal to 2. Problem is over. If all 2 by 2 is also 0 in a given 3 by 4, then rank is not equal to 2. Then your next level is 1 by 1. There you find a 1 by 1 means one non-zero element. One non-zero element determinant is always not equal to 0. Okay, once again I am defining this single sentence. Find the highest square submatrix and then determinant. If that value not equal to 0, then the order of the highest square submatrix is called the rank of the matrix. Okay. Rank of a matrix. A is denoted by, this is a Greek letter row A or R of A or just rank A. So non-negative integer means either 0 or positive integer. If all the elements in a matrix are 0, that is called a zero matrix. Such matrices have rank is equal to 0, because we cannot find a highest order non-singular square submatrix. If a matrix is a null matrix, there cannot exist a 1 by 1 or 2 by 2 or 3 by 3 square submatrix non-singular, means determinant not equal to 0. So that's why rank of a null matrix is 0. Rank of a null matrix is 0. Automatically rank of a non-zero matrix is always greater than or equal to 1. So rank of every matrix is always greater than or equal to 1 except zero matrix, that is null matrix, because rank is equal to 0. Okay. So we will do 2 problems. After that we will give 1 mark note points or results, and then other method for rank using row or column operations or both. Find the rank of the following matrices. 1. Just a second. 1, 2, 3. 4, 7, 6, 9, 5, 3. Second example, which is given 2012 GATE. 5, 3, minus 1, 6, 2, minus 4, 14, 10, 0. Solutions. First one. So here both matrices are square matrices. In the first problem, the matrix is square matrix. What is the highest square submatrix? The matrix 3 by 3 itself is a highest square submatrix. So immediately find determinant. If your determinant not equal to 0, then rank is equal to order of the highest square submatrix, that is 3. Suppose if 3 by 3 determinant 0, then what is our next level? Find a 2 by 2 determinant not equal to 0, then rank is equal to 2. If you do not find 2 by 2 matrix whose determinant is non-zero, then your rank is equal to 1. That is going by decreasing level, descending order. Okay. You start with highest square submatrix determinant. Wherever you get not equal to 0, then the problem is over. Rank is equal to order of the highest order non-singular submatrix. So I am taking the given matrix A, so that I am finding determinant A. You know the procedure for 3 by 3 determinant. 1 into 21 minus 30 minus 9. The middle element 2 into with minus. Yesterday I explained 2 to 3 problems procedure of determinant. I hope that you all practiced. Okay. Minus 2 into 12 minus 54. 12 minus 54 means minus 42. Plus 3 into 20 minus 63. That is minus 43. So whatever it may be, see this minus 9 plus 84 minus 129, whatever it may be, irrespective of the answer. So we say it is not equal to 0. Therefore, rank A is equal to 3, because the highest order, that is, this is denoted by R, since A itself is of highest order non-singular square submatrix. Not required to mention square, because non-singular singular words comes to submatrices, square matrices only, submatrix. I written the reason. Okay. Now, so det not equal to 0 means that matrix is called non-singular. Okay. Wherever you get highest order non-singular, determinant not equal to 0, then rank is equal to that order. Problem is over. Okay. Second example. Similarly, I am finding determinant A, because it is a square matrix. The 3 by 3 is the highest submatrix in itself. Okay. 5 into, or you can expand by any row or any column where the elements more, where it contains more zeros. Okay, no problem. 5 into 0 plus 40, middle number plus 3 into minus 0 plus 56, minus 1 into 60 minus 28, that is 32. Now, this is 200 and this is minus 168 minus 32, that is 200 minus 200 simplifies to 0. Okay. So, rank A not equal to 3, because 3 by 3 determines 0. Now, what is your next level? Find a 2 by 2 matrix. Just see here, I highlighted these 4 elements, gives a 2 by 2 submatrix whose determinant 10 minus 18 not equal to 0. And there exist, this is the symbol meaning there exist a minor of order 2, that is 5, 3, 6, 2. How much? 10 minus 18, minus 8 not equal to 0. That is, there exists a non-zero minor of order 2, because we got last one not equal to 0. That's why I didn't write here non-zero. Okay, because we got not equal to 0. Therefore, rank A is equal to 2. So, from these two examples, we can conclude 2 note points, 1 mark result. If the matrix A itself is non-singular, that is determinant not equal to 0, rank is equal to order, that is n. If a matrix is singular, that is determinant is equal to 0, then rank less than n. N is the order of the matrix, square matrix. Here we got rank is equal to 2, order of this square matrix is 3, 2 less than 3. Okay, copy down. So now I am giving a few points, 1 mark results, which are useful in GATE exam. GATE point of view, I am giving 1 mark questions based on these 2 examples, or if you do not understand that point, consider the corresponding example 2 by 2, 3 by 3, or any the corresponding to that point. You consider some matrix example, you apply and check it whether it is correct or not. If it is not correct, then I will prove it. You always begin in the first method, that is highest square submatrix determinant. When it is not equal to 0, your problem is over by that step and rank is equal to highest order. Whenever it is 0, then go by your next level, highest submatrix. Wherever you get not equal to 0, then the rank is equal to that order, problem is over. Note. If A is non-singular matrix of order n, then rank of that matrix is equal to n. If A is singular matrix of order n, then rank A less than n, that is less than or equal to n minus 1 also. These two tells that the previous examples. Okay. 2. If A is of order m cross n, maybe square or rectangular matrix, then rank A, that is row A, less than or equal to minimum of m comma n. So m stands for number of rows, n stands for number of columns. Find minimum of these two. Then rank of that matrix is always less than or equal to this minimum. That means it tells that rank of a matrix never exceeds, that is never greater than rows, number of rows as well as number of columns. Okay. 3. Rank of In is n. In means n by n identity matrix, because determinant I value I gave yesterday 1 not equal to 0. So identity matrix is non-singular. As above first point, then rank of this matrix is n. Rank of a diagonal matrix slash triangular matrix, that is either upper triangular or lower triangular, is equal to number of non-zero diagonal elements. See, here also I can write In along with scalar matrix. In slash scalar matrix of order n is n. So scalar matrix means all equal to scalar, I have explained, because scalar matrix determinant is not equal to 0, n. 0 matrix don't compare with scalar matrix. 0 matrix I have given already, rank is equal to 0. A and A transpose have same ranks. Rank A transpose is equal to rank A. 5th point. Rank of a matrix is unaltered, that is not changed, by the elementary operations. Elementary operation means row column operations. Only row or only column or both. Rank of a row slash column matrix is always 1. Now see, these points I verified. This is going I mean, you can check with square matrix also. Rectangular matrix I didn't find the rank so far, which will I mean, this I can prove by a problem in the next method. Don't worry. Rank of identity matrix, I told you, scalar matrix of order n determinant not equal 0, that's why is n, which is came by this point only. Rank of a diagonal matrix, triangular matrix, you know that number of non-zero diagonal elements. Why? Because if one diagonal element 0, then determinant is equal to 0. Okay, that means in a 3 by 3 matrix, all 3 diagonal elements are not equal to 0, then rank not determinant not equal to 0. Okay, in a 3 by 3 diagonal matrix, if one diagonal element 0, that means 2 other elements are non-zero. Definitely there is a 2 by 2 whose determinant is not equal to 0. There is a 2 by 2 submatrix whose determinant is not equal to 0. Okay, that means rank of a diagonal or triangular matrix is equal to number of non-zero diagonal elements. Number of non-zero diagonal elements. For example, see 1 0 0 0 2 0 0 0 3. So this square matrix, this is the diagonal matrix. If you find the determinant which gives not equal to 0. Okay. So rank of this diagonal matrix is equal to number of non-zero diagonal elements, that is 3. 1 0 0 0 1 0 0 0 0. This is also a diagonal matrix, but one diagonal element is 0. So determinant gives 0. Now there is a 2 by 2 submatrix 1 0 0 1 whose determinant value not equal to 0. That's why rank of this diagonal matrix 2 and this matrix 3. Here 3 non-zero diagonal elements, so rank is equal to 3. Here 2 non-zero diagonal elements in a diagonal matrix I am telling. So rank is equal to 2. Okay. Similarly, it is also true for upper triangular as well as lower triangular. The number of non-zero diagonal elements is called the rank of the matrix. Okay. Next, A and A transpose have same ranks. For example, if you consider this matrix or this matrix, just now I proved rank of this matrix 3, rank of this matrix 2. Transpose. On transposing this matrix, you will get this only. Okay. Same determinant is also not equal to 0 for the first case, and I have given yesterday determinant A is equal to determinant A transpose. Due to that we will get, that means due to that we will be getting A and A transpose have same ranks. Okay. Rank of a matrix is unaltered by the elementary operations. Suppose once we find the rank of a given matrix, okay, put aside that answer. Take the given matrix again. Apply whatever you like, row or column or both operations. So you will be getting some matrix. So find that matrix rank, that matrix obtained rank, okay, using the above method options. I mean, using the above method means so far we have done 2 problems only. Okay. So then rank never changes whenever you apply any operations, row or column operations. Okay. Rank of a row or column matrix is 1. So what is row matrix? For example, see 1 2 3. This is a 1 row 3 columns. So in 1 cross 3 matrix there cannot exist 3 by 3 matrix and 2 by 2 matrix. What is the highest square submatrix? 1 into 1, that is 1 by 1. So what is 1 into 1? It is a 1 element. So there is a 1 into 1, say here 1, whose determinant is not equal to 0. So that's why rank of this row or column matrix is 1. Okay, because transpose of row is nothing but column, that's why rank of a column matrix is 1, because I gave already A and A transpose have same ranks. Okay. And 2 more points are there. 7. Rank of a product of 2 matrices less than or equal to, that is never exceeds, that is never greater than either of the ranks, that is minimum of rank A comma rank B. So find individually the given 2 matrices ranks. Okay, keep on one side, and then from the given matrices find the product. After that find the rank. So always that obtained rank is less than or equal to either of these ranks. Okay, take any 2 matrices randomly, you check later. 8. Rank of the sum of the matrices never exceeds sum of their ranks. And rank of difference of 2 matrices never succeeds, that is never less than or equal. rank A minus rank B. So just by heart, sometimes these are 1 mark questions. That means we may expect these points as 1 mark questions. So keep these things in mind and remember that the definition of the rank of the matrix with the 2 conditions. Okay, and now I am giving the alternative method using row operations or column operations or both. Okay, to find the rank of the matrix. That is the called echelon form, ECHELON, of a matrix. MAT stands for matrix. A matrix A m cross n is said to be in row echelon form. There are 2 types, row echelon and column echelon form, but problems no importance given to column echelon form. That is because of just the transpose of this row echelon form. Row transpose is column. If, here also 2 conditions. 1, 0 rows if any belong at the bottom of the matrix, last of the matrix. 2, the number of zeros before a first non-zero entry or element of each row is less than the number of such zeros before a first non-zero entry of its next rows. Copy down. Now let me explain. What is zero row? In a row all elements are zeros, that is called zero row. If that zero rows present in the first level or middle level of the given matrix, you just send into last level by interchanging of 2 rows operations. That is belongs to the bottom of the matrix, belong at the bottom of the matrix. Okay, in the given problem, if it is first row is zero row, you send it to last row by interchanging of row operations. That is first operation done. Second operation, second step, the number of zeros before a first non-zero entry of each row. So now try to understand, this point is very difficult. After giving an example, then it becomes very easiest method. Go to first row, find the first non-zero element, count the number of zeros before first non-zero element. Okay, so keep in that mind. Okay, come to second row, find the first non-zero element. Similarly, count the number of zeros before first non-zero entry. So that number of zeros compared to the preceding number of zeros, it is always increases. Okay, the number of zeros in the first row before a first non-zero entry is less than the number of zeros before the first non-zero entry of next rows, means second row, third row, like that. That means the meaning of this point is the zeros increases by row. Okay, the zeros increase, the number of zeros increases row by row before a first non-zero entry of each row. Okay, I will give you the example. Note, after reducing the matrix A m cross n into row echelon form, comma, the number of non-zero rows is called rank of A. Rank of A. That is the advantage of echelon form. After reducing these two steps, that is by doing these two steps, you will get row echelon form. Then what is the advantage? To determine the rank of the matrix, how to determine the number of non-zero rows. Okay, just see example. 1. A is equal to 0, 1, 2, 3. 0, 0, 0, minus 1, 0, 0, 0, 0, which is a 3 by 4 matrix. Now, go to first row. Where is the first non-zero element? This is, just I highlighted by circle. In the second row, where is the first non-zero element? This is. In the third row, no non-zero element. So, here, what is the first condition? 0 rows belongs to last level. Now, count the number of zeros from first row onwards before a first non-zero entry. So here 1 0 before first non-zero entry in the first row. And there are 3 zeros before a first non-zero entry, here minus 1 in the second row. That means zeros increases level by level, row by row or not. That means strictly speaks that in square matrix, or of course for understanding purpose, whatever the matrix, the elements below the diagonal are 0. The elements below the diagonal are 0, that is called row echelon form. Similarly, the elements above the diagonal 0, that is called column echelon form. Actually, diagonal corresponds to square matrix only, but for understanding purpose I am telling. Okay, that means the number of zeros increases row by row before a first non-zero entry of each row. Okay, here how many non-zero rows? What is non-zero row? At least one element in a row is not equal to 0. That row is called non-zero row. So here this is in row echelon form, since it contains two non-zero rows. Therefore, rank A is equal to 2. The same problem, that means rank, I can verify by the fundamental method, that is today we have started, determinant method. Here 3 by 4. What is the highest square submatrix? 3 by 3. So, the first 9 elements form a 3 by 3 matrix. Determinant is 0. Because in a determinant, a row or a column completely zeros, the determinant is equal to 0. Yesterday we have discussed the properties. Like that, first, second, third column, 3 by 3 matrix. First, second, fourth column, 3 by 3 matrix. First, third, fourth column, 3 by 3 matrix. Second, third, fourth column, 3 by 3 matrix. So, in a 3 by 4 matrix, how many 3 by 3 square matrices? 4. In each 3 by 3 square submatrix, the one row completely zeros. So, that's why determinant equal to 0. That means, here, the 3 by 3 determinants are all equal to 0. What is your next step? By comparing with your previous method, 2 by 2 matrix. In the given 3 by 4 matrix, you search or find a 2 by 2 matrix, submatrix, whose determinant is not equal to 0. See, for example, these 4, what is the determinant? 2 into minus 1, 3 into 0. So minus 2, determinant not equal to 0. So 2 by 2 determinant not equal to 0. So hence rank is equal to 2, that is compared by previous method. Okay, every method, every problem can be compared by whatever the method. But reducing the matrix into these types, row echelon form, you have to do operations, row column operations. Better to apply row operations while reducing into row operations. You will not get mistakes. Okay, you can apply column operations also. Okay, so no importance given to column echelon form, that is just the transpose of this form is called column echelon form. Okay. The entire system of linear equations depends on row echelon form procedures only. Okay, take care about these things. One more example I am giving. After that, two problems, how you reduce into these examples. Okay, I will do it. Second one, A is equal to 1 0 0 0 minus 2 0 0 0 3. Now in the first row, the first non-zero element is 1. In the second row, the first non-zero element is minus 2. In the third row, the first non-zero element is 3. Here no zero rows, that means no need to check first condition. Come to second condition. The number of zeros before this first non-zero element in the 1, that is 1, that means no zeros, 0 zeros. The number of zeros before this minus 2, what is this minus 2? The first non-zero element in the second row, 1 0. The number of zeros before the first non-zero element, that is 3, in the third row, how many? 2. So here 1 0, here 2 0, that is zeros increase row by row, that means below the diagonal elements zeros are not. So in the same, above the diagonal elements are also 0. So this is both row echelon form as well as column echelon form. Is both row and column echelon form since it contains 3 non-zero rows. Therefore, rank A is equal to 3. You can apply the previous problem method, rank method, determinant not equal to 0. Diagonal matrix, 3 non-zero diagonal elements, which have so many properties comparing the methods. Okay, comparing that rank procedures. Next. So every upper triangular matrix is a row echelon form. Every lower triangular matrix is a column echelon form. But the converse need not be true. What is converse need not be true? Whenever a matrix is row echelon form, it may or may not be upper triangular matrix. See, this is 3 by 4 rectangular matrix. We cannot compare the rectangular matrix definition into upper triangular matrix, lower triangular matrix, even though it is row echelon form. Okay, just for understanding purpose, I told that point, a very important point. Reduce the elements below the diagonals are 0. Make the elements below the diagonal 0. Make the elements above the diagonal 0. See, if you make the elements below the diagonal 0, that is called row echelon form. If you make the elements above the diagonal 0, that is called column echelon form. For understanding purpose, I am giving this point. Okay, actually below the diagonal, above the diagonal stands for square matrix only. Okay, for understanding purpose only, I have discussed like that. Every identity matrix, every scalar matrix, every diagonal matrix is both row echelon form as well as column echelon form. But no importance given to column echelon form because we have habituated with row operations, not row operations. So for the solving system of linear equations, almost all the problems bringing into row echelon form only. Okay. Please remember, every diagonal matrix, scalar matrix, identity matrix, both row and column echelon form, simply called echelon form. Okay. Find the rank of the matrix is 1. So whichever the method what you feel better, apply that method. Okay, either determinants method or row operations, column operations after reducing into row echelon form. This is given GATE 2003, 2 marks. 4, 2, 1, 3. 6, 3, 4, 7. 2, 1, 0, 7. Second example. 2, 3, 4, 5. 3, 4, 5, 6. 8, 9, 10, 11, 13, 12, 14, 15, 16. One is 3 by 4 rectangular matrix, other is I took square matrix. And after this, 2 more problems I am giving you along with answer. Later you check whenever you are free. Now, solutions. First one, let us say the given matrix is A. 4, 2, 1, 3. 6, 3, 4, 7. 2, 1, 0, 7. Now bring this matrix into the above definition, that is row echelon form, which I have given 2 examples. Bring into that examples using by operations, row column operations or only row operations or column operations. Now you observe which operations I am doing. Okay, just I am giving an indication. This diagram indicates the first non-zero element in the first row is 4. That's why I highlighted. So that means finally what I told, below the element 0. That's why the elements exactly not only below the first non-zero element 0, but also left to the elements. That means the elements left to the circle and down elements are also zeros. Okay, circles means here for understanding purpose I drawn that circle. Circle means the first non-zero element in a row. Okay, and the arrow indicates make the corresponding element 0. So now onwards I am giving this type of circles arrows. Each circle indicates the first non-zero element in a row. The arrow indicates the elements correspondingly, make them to be 0 using row operations. Okay, I told you yesterday this type of directions arrows, column operations. This type of directions arrows called row operations. So 6, 4. Make 6 is equal to 0 and 2, 0 with the help of this 4. 6 located in R2, 2 located in R3, 4 located in R1. Now see the operations. R2 changes to 2R2 minus 3R1. How? 6 and 4 LCM is 12. So we have to make these two 12 by multiplying this with 2 and this multiplying with 3 and then subtracting. Okay. So 2 and 4 LCM is 4. So we have to get 4 here. That means R3 changes to 2R3 minus R1. This simplifies to next matrix. Okay. 4, 2, 1, 3. 0, 0, 5, 5. 0, 0, minus 1, 11. Okay. Now first step, first row over, come to second row. This is our first non-zero element. Immediately make its lower element 0. That means we have to make minus 1 third row element with the help of this 5 second row using row operation 0. So to get 5 here we have to multiply R3 with 5. That means 5 R3 plus R2. Where you put this value, R3 changes to. So you will be getting in matrix 4, 2, 1, 3. 0, 0, 5, 5, 0, 0, 0, 60. Now go to third row. No more rows after third row. So here, see, before first circle no zeros, before this circle 2 zeros, before this circle 3 zeros. Zeros increases. Each circle indicates the respect to first non-zero element in the row. Okay. Therefore, A is in row echelon form. How many non-zero rows? 3. Hence rank A is equal to 3.